using physicochemical parameters, that is QSAR. So we have already discussed like the mathematical equation is correlated with the biological activity. Am I right? So what is this line called as? Anyone? We are finding a line which correlates the biological activity. This line is called as the line of the line of resting. That means we are taking a X compound. The substance in the X compounds are equated. You are understanding the biology as well as the physical and chemical properties. The physical and chemical properties are equated, and the best equation which gives the maximum biological activity. The best equation which gives the maximum biological activity is called as the line of recipe. This is called as what? The line of recipe. That is nothing but the compound can fit into the receptor theoretically. The compound can be fit into the receptor theoretically. So the receptor and the drug can go for maximum binding. The receptor and the drug can go for maximum binding. So in QSAR, we have to remember the electronic parameter, steric parameter, tap steric parameter, sterimol parameter, minimal steric difference, Verloop's parameter, etc. I'll repeat. In the quantitative structure activity relationship, in order to find out the line of best fit, we are having certain parameters. The physicochemical parameters are classified as electronic parameters, steric or steric parameters, tap steric, the scientist was found out as taps, and the minimal steric parameter, Verloop steric parameter, sterimol parameter. Okay, so what does it mean? So we can see one by one. So the first one is called as electronic parameter, and this is found out by the scientist Hammett. So the electronic constant is found out by the scientist Hammett. So the electronic parameter or electronic constant is called as Hammett's constant. The electronic constant or the electronic parameter is termed as Hammett's constant. The notation is sigma. What is the notation for the electronic parameter? Sigma. So we will take one example. In case of anti-infective agent. So what is the anti-infective agent? What is meant by anti-infectives? Local anti-infectives. Anyone have to define local anti-infectives? Local anti-infectives. What do you mean by infectives? Infectives are caused by microorganisms. What are the microorganisms? Bacteria, fungus, virus. So you imagine in this floor, if you are cleaning the floor with dash, what is the dash? Disinfectant. What is meant by disinfectant? The agent which prevents the growth of microorganisms. So the agents which can prevent the growth of microorganisms. If it prevents, it is called as dash static, bacteriostatic. If it kills the microorganism, it is called as bactericidal. It is called as bactericidal. So we will take a class of anti-infectives. In that anti-infectives, we are taking benzoic acid. What is benzoic acid? What is benzoic acid? Monocarboxylic acid. It is aromatic monocarboxylic acid. So in this, we are taking this as unsubstituted This compound is taken as unsubstituted compound. The compound taken as unsubstituted. So one hydrogen is substituted with an electron withdrawing group. What is that? Electron withdrawing group, which can produce a negative inductive effect. Which can produce a negative inductive effect. So the negative inductive effect means the groups attached to the covalent bond is not mutually shared. So what is a covalent bond? What is meant by a covalent bond or sigma bond? Single bond. What is meant by a single bond? In single bond, the electrons are distributed equally. The electrons are distributed equally. So there is a mutual, that is called as mutual sharing of electrons. When an electron withdrawing group is present, what will happen to this carbon? What will happen to the electronic load of the carbon? If there is an electron withdrawing, imagine you are connecting two carbon atoms. You are connecting carbon and hydrogen. So carbon and hydrogen are called as two similar electronegative elements. Carbon and hydrogen are called as two similar electronegative. That means they are having similar chemical properties. That means they are having similar chemical properties. Excuse me. If an electron withdrawing group is present, this will pull the electronic cloud towards itself. This will pull the electronic cloud towards itself. This is called as negative inductive effect. This is called as what? Negative inductive effect. So when you come across monohalogenated, dihalogenated, trihalogenated, you can assume that the anti-infective property is enhanced. The anti-infective property or the bactericidal effect or the bacteriostatic effect is enhanced when the induction is more. When you have more number of inductive groups, negative inductive groups, the biological activity is enhanced. Okay, so this equation says delta is equal to Kx divided by Kh. What is delta? Delta is equal to Kx divided by Kh. This is unsubstituted benzoic acid. This is what? Unsubstituted benzoic acid. This is substituted benzoic acid. This is substituted benzoic acid. So this sigma can also be written as logarithmic Kx minus logarithmic Kh. So you can note the two equations. Sigma is equal to Kx by Kh or sigma is equal to log Kx minus log Kh. So in fact the logarithmic K by B can be written as log A minus log B. So this is Hammett's constant. So halogenated groups enhances anti-infective effect. What are the halogenated groups? The groups which are having negative inductive effect. This is called as, here the biological activity is based on which property? The biological activity is based on dash property. What is the property? Electronic property. What is the property? Electronic property. That's why it's called as electronic parameter. That's why it's called as what? Electronic parameter. So to summarize, what are the previous year parameters? Hammett's constant, steric parameter, sterimol parameter, Bernoulli's, etc. And in that we have seen today sigma. What is sigma? Hammett's constant. Hammett's constant is equal to logarithm of Kx divided by Kh. Kh is unsubstituted. Kh is unsubstituted. We are taking a series of aromatic monocarboxylic acid. What is that aromatic monocarboxylic acid? Benzoic acid. So we are concluding here, sigma is equal to logarithm of Kx minus